Hi guys. So today I'm going to present you a very interesting topic called syllogisms. Syllogisms is a fairly easy topic if you understand the concepts well. I'll start with the basics and then later deal with some trickier problems or some tough problems. Questions involving possibilities, at least, questions with options either or. So these topics I will cover during this tutorial. After this tutorial, you should be able to solve any syllogism questions using diagrams. Let's start. So in syllogisms, you'll get sets of statements like all A's are B's, some A's are B's, no A is B, and some A is not E. So any syllogism questions will consist of few of these four statements. So let us try to understand each statement one by one. All A's are B's. So we draw A and then we draw B such that all of A are B, right? All of A are B. There's another possibility to it. Here also we have drawn A and we have drawn B on top of A such that all portion of A are B and all portion of B are A. So keep in mind with these two possibilities. Just remember, when we have all A's are B's, we draw A. We just have to make sure that all portion of A is inside B. It doesn't matter whether you stretch it to cover whole of B's areas or part of B's areas. Just make sure that this statement is valid. All of A's are B's. Some of A's are B. So we draw A and we draw B such that at least some portion of A are B. So we draw B at least some portion of B are A. This we can also achieve by drawing this, right? So at least some portion of A are B. In this case also, we just have to make sure that there is at least some portion of A which are in B. So at least some, right? I mean, there is some portion here also. There is some portion of A. So these are the two possibilities in this statement. No A is B. So we draw A and B separately such that there is no overlap of A on B or no overlap of B on A, right? So no portion of A. So no portion, all these portions, none of these portion of A are in B. For this will always give a cross mark or restriction symbol saying that, meaning that no portion of A are in B. Use this statement, guys. I will, as we go ahead in tutorial, we'll understand why using these cross mark notation will be very helpful in negative statement like no, not, some not. So let us see. Some A is not B. We draw B and we draw A such that some portion of A is not B. So here we can see that some portion of A are not B. There should be at least some portion of A which is not B. In this case also, there's at least some portion of A which is not in B. But here in the second possibility, there is no such thing that some portion of A is not in B. All portion of A is in B. So to distinguish between this statement and this statement, we'll add an additional restriction symbol here saying that there has to be at least some portion of A which are not in B. Here also you can see that this is still valid. There is at least some portion of A which is not in B. So there are these two possibilities here, right? Just to make the diagram more clearer, you can, if I try to put all portion of A inside B, we can't still put because of this restriction. There's no possibility that all portion of A is in B because the statement says some of A should not be B. So there is at least some portion of A which should not be in B. Let's move ahead. Question 1. So statement A says some desks are chairs. So we draw desks and we draw chairs such that at least some portion of desks are chair. So we'll draw chair like this, right? At least some portion of desks are chairs. Some chairs are pens. So we draw pens such that there is at least some portion of chairs which are pens. Some pens are drawers. So we draw drawers such that at least some portion of pens are drawers. right? So this basically sums up our diagram. Remember here is that we are not drawing the possibility statement, thus we are only drawing the basic diagram. I know some desks are chair also mean that all desks can be chair, but that is a possibility. We will always draw the basic diagrams and not the possible diagrams. Until and unless we don't have any restriction statements like cross marks, we are free to imagine in whatever way we can. That will get more clear to you as we move ahead in this tutorial. Let us try to validate the conclusion. Here we are given 3 conclusions. We have to identify which all conclusions are always valid. Which all conclusions are always valid. Let us see conclusion 1. At least some drawers are desks. So at least some drawers are desks. So here is desk, here is drawer. So is it true that there has to be some portion of drawers which are desks? No, right? Here we can't see. It is a possibility, all right, that at least some drawers are desks, but saying that this is a definite conclusion would be false. There is a possibility all drawers are chairs. Statement number 2. There is a possibility that all drawers are chairs. So we don't have any restriction statement. So we have these possibility that all drawers are chairs. We don't have any restriction between chairs and drawers. So we can as well put drawers inside chairs. So there's a possibility that all drawers are chairs like this. Okay, no drawers is a chair. No drawer, so no portion of drawer is a chair. It is a possibility, all right, like this. It is a possibility that no drawer is a chair, but since we don't have any restriction, cross mark symbol here, so we can't say for sure that no drawers are chair. Had that been true, we would have a restriction statement with cross mark that no drawers are chair, and we clearly have no restriction symbol here. So the answer for this question would be there's a possibility that all drawers are chairs. Okay, moving to question number 2. All benches are cot. We'll draw cots such that all portion of the benches are cots, right? All of the benches are cots, so all portion of the benches will be inside cots, right? No cot has a lamp, so we draw cots and we have lamps. We mark this with cross symbol. This says that lamp could not be, there could not be any portion of lamp which is inside cots. It is denoted by a cross symbol. Statement number 3. Some lamps are candles, so we draw candles such that some of the lamps are candles. So some portion of the lamp has to be candles, so we draw like this. So let us see our conclusion. Let us try to verify whether these are definite conclusion. Some cots are candles. Some cots are candles. This is a possibility. Since we don't have any cross mark between candles and cots, we could have as well drawn candles such that it covers some portion of cots. But this is not a definite conclusion. Here the question is not asking whether, the conclusion does not say some cots are candle is a possibility. It says some cots are candles. Some cots are candles. No, some cots are candles need not be true. There can be candles which are not cots, as we can see from the diagram. So idea is to draw the basic diagram and try to see all the possibilities with respect to these symbols, cross symbols. If there is no restrictions, we have possibility. But here the question is not dealing with possibility. The question is saying it's a definite statement. Some cots are candles. Some candles are cots. So we have some candles which are cots. These two are basically the same statements written in a reverse manner. Some cots are candles, some candles. So again, some candles need not be cots. So both the statements are false. So no conclusion in that case. Question number 3. Some blondes are stupid. So we draw blondes. We draw stupid such that there is at least some portion of blondes which are stupid, right? We have some boys are blondes, so we draw boys such that there is at least some portion of boys which are blondes. all stupids are girls, so we'll draw girls on top of stupids such that all of the stupids are girl. Hilarious statement, but yeah, I mean, so these statements need not be true. All stupids are girls. Fine. Let us see conclusion one by one. Some stupids are blondes. Some portion of the stupids are blondes. It's a right statement. Some girls are blondes. Some girls are blondes. Clearly right statement. Some boys are stupid. So there has to be some boys which are stupid. Again, it's a wrong statement. So no conclusion here as well. Right? Sorry, some stupids are blonde. These two I said are right. So conclusion 1 and 2 are correct conclusions. Right? Some stupids are blondes and some girls are blondes. We can clearly see from the diagram. So, alright. So let's see a more trickier problem. It's tricky because of the options like either or. Let us try to build a diagram first. All bricks are tricks. So we draw bricks and we draw tricks as that all of the bricks come inside tricks. Some tricks are bigs. So some tricks are bigs. See the difference? This is bricks and this is bigs. Don't get confused. So we draw bigs such that some of the tricks are bigs. So at least some portion of the tricks are bigs. Let us try to see the conclusion one by one. No brick. So let us try to see conclusion one by one. No brick is a big. No brick is a big. We don't have any cross statements here. So this is not a definite conclusion. There is a possibility that some portion of the bricks some portion of the bricks might come inside bricks. So since there is no cross statement here, this is not a definite conclusion. Some bricks are bigs. Again, some bricks are bigs. This is also not a definite conclusion since they cool. Some bricks are tricks. Some bricks has to be tricks. So right, all bricks are tricks, alright, but some bricks are also tricks. We discussed, right? Some means all also in the first diagram. Okay, some tricks are not bricks. Some of the tricks are not bricks. No, right? So this is also we can't say for sure that some of the tricks are not bricks. Some of the tricks are not bricks. We can't say for sure, right? All of the they can be tricks which are bricks also, right? There can be a possibility that all of the tricks are bricks, right? If we overlap this, some would still hold. So we have option 3 follows, 2 and 3 no. So we are left with these two options. Let us see. Option A is true for sure. Let us try to see option this. Now either or conditions comes into picture when there is a negative statement, no statement, and there is some statement or all statement, a negative and positive statement, right? So here we have a no statement, either one. Check whether either of 1 or 2 follows. There can't be a situation where both 1 and 2 are wrong. So either. So let us try to see. 1 says no brick is a big. No brick is a big. So no brick is a big. 1 says that no brick is a big. Or 2 says some bricks are big. Some bricks are big. So either no part of brick is a big, or if there is, so in this case diagram there is no brick, or there has to be some portion of brick which is big, right? Both can't be false at a time. So look at either or statements carefully. Either no or some. So either no portion of the bricks is a big, or there has to be some portion, right? So this is the right conclusion. Before we move on to some trickier problems, try to understand these statements. I'm saying draw only what is given, don't draw possibilities, as we says, right? If there's some, draw only some, don't draw all, right? So draw only basic statements. We know what all things can be possible if you know your diagram well. So if we haven't marked any cross mark statements, we know that there's always possibility that this thing can come inside this, or this can come inside this, until and unless there is at least some part of A which overlaps with B. So don't draw possibilities. Keep in mind there are infinite possibilities, only restriction condition restrict possibilities. So in this case, in this particular diagram, we have a cross statement, so there has to be some portion of this which is not part of this, right? Some portion of A which is not part of B because of this cross statement. Represent restrictions carefully. This is very important, guys. Restriction is very important. You'll understand it why when we move ahead with more trickier problems which comes in various competitive exams. In competitive examinations, you'll rarely get very simple statement. You will get questions involving possibilities, at least, either or. So know what you draw. You understand it? If there is no cross statement, there is this possibility. So when we say this and we don't have a cross statement, so it could be whole overlap. Both the statement can be overlapped also, A equal to B, right? So know what you draw. Let's move ahead. So let us attack this question. All flowers are trees, so we draw flowers. We draw trees such that all flowers are trees. Some trees are houses, so we draw tree houses such that some portion of the trees are houses. So we draw houses such that some portion of the trees are houses. All houses are wheels, so we draw wheels over top of houses such that all the houses are wheels. Alright, let us see the conclusions. At least some wheels are trees. At least some wheels are trees, clearly true. There is at least some portion of the wheels which are trees, because houses overlap with trees and all the houses are essentially wheels, as we can figure out from the diagram. Some trees are flowers, some trees are flowers. So some trees are flowers, so this portion of the tree is flower, so this is also right. All wheels are flowers. All portion of the wheels are flowers is a possibility, it is saying. So all portion of the wheels are flower. Obviously we have some statements, some portion of the wheels is trees. Now if we move all the wheels inside flowers, it is a possibility. And as I said before also, we don't have any cross statement here, so this possibility exists. We are not restricted by any cross statement, so we can move all inside this. So answer would be all the three statements. What if we add a negative statement here and this, and then we'll try to check this particular conclusion whether this is true. This remains same, these two are true, this will change. Let us see how. So there's fourth statement which gets added here. Some wheels are not trees, so some portion of the wheels which are not trees. So what is missing here? We have a restriction statement. So we draw a restriction that there has to be some portion of the wheel, some portion of the wheel which are not trees. There has to be at least some portion. No matter if you try to put inside, there has to be at least some portion of the wheels which are not trees, because this is cross, so we can't possibly put all wheels inside this. Now if we try to look at this statement, all wheels are flowers. So for all wheels of flower, this also need to be put inside this, this also need to be put inside this, but we can't because of this restriction statement. It says, this cross statement says that there has to be some portion of the wheels which are not trees, so we can't go inside this because of this. So this is very handy, man. This you always should draw. So in no statement you will draw like this. In some not statement, draw like this, saying that some portion of this particular figure is not this, right? So it's always a possibility. So now what if we add Another conclusion. Okay, no, sorry, this is a new question. So all reds are white, we draw red such that all of the red is white. Some white are pink, so we draw pink. So we draw pink such that some portion of the white are pink. Some pink are yellow, some pink are yellow, so we draw pink. We draw yellow such that some portion of the pink are yellow, right? So we draw like this. Some portion of the pink are yellow. Now last statement is no yellow is blue. So we draw blue such that no part of yellow is blue. So we draw blue separately, not overlapping, because these are not overlapped. No portion of yellow is blue. So we'll give a cross restriction statement here, a restriction symbol here. Let us see conclusion one by one. No blue is pink. So no blue is pink. There's no restriction statement between these two, right? There's no. So if we could as well draw blue here, make the restriction statement here, blue here like this, and make the restriction statement here. This is blue, right? Sorry for bad handwriting with mouse. Okay, so we could as well have drawn like this. So some pink are okay, no blue is pink. So no part of blue is pink is a false statement, because there exists it is not a definite conclusion. If it says that no blue is pink, it's saying it's universal now that no blue is pink. It's not universal. There is a possibility that some portion of the blue is a pink, so this is wrong. Some pink are red. Some portion of pink are red. Not necessarily. We can't say for sure that some pink are red. Here there's no pink. If it had it said that some pink are red is a possibility, then it would be a true statement like this. Some pink are red is a possibility. No, it is a possibility. We don't have any cross a restriction symbol here, so we can as well move pink in this direction such that there is at least some portion of pink which is red. So this is true. Some blue are red. Some portion of the blue are red. Again, not a definite statement, not a definite conclusion, not universally true. Some blue are pink. Some portion of blue are pink. Again, not a definite. So only 3 is true. What if we add another statement here that all pink is blue is a possibility. All pink, all portion of the pink are blue. So all pink come inside this. Now we don't see a restriction statement here, so now this statement doesn't exist. This statement doesn't exist, so we can actually put pink inside blue. But wait, we can't put this particular thing inside blue, this portion of the pink inside blue. We can put rest of the pink inside blue, but not this portion, because this is restricted, because this is also part of yellow, and no yellow is blue because of this symbol. So this statement is, this portion of the pink is restricted to enter blue. Just try to imagine, right? So just try to imagine, right? Here we can put all portion of the pink inside blue, but not this particular, because of restriction, not the yellow portion of the pink. So all pink being blue is not a possibility in this case. Some pink are definitely not blue. So this was pink, right? So some pink, this portion of the pink is definitely not blue, so this statement is right. So thank you very much.